Hey guys, welcome back. So today I wanted to give an introduction on networks and just some brief ideas and concepts that you'll need to know in the standard course. Now, I find that every year I teach this, the kids always kind of come back to me and say, this is not even maths, this is so whack. And I get it, it's a little bit strange. But the more I teach it, the more I actually enjoy teaching it because I find it relatively interesting. And to be honest, as a maths teacher, it's a nice break from having to do the regular calculation. So the basic idea of networks is just a basic way of representing a connection between things or people or even ideas, just anywhere where there's a connection. So a famous example is called 6 degrees of separation, which basically says that me and, let's say, my friend Doug, that is 1 degree of separation because we have a direct connection. Let's say Doug has another friend called Charlie. Me and Charlie have 2 degrees of separation. So it goes from me to Doug, Doug to Charlie. Now, 6 degrees of separation basically says that you only need 6 degrees of connection such that you can reach anyone in the world. So, for example, there's probably only 6 steps. Well, mathematically, I guess, there's only 6 steps between, let's say, me, Cristiano Ronaldo, Margot Robbie, and you. So I find that pretty interesting that, there's 7 billion people and you only need 6 degrees of separation to connect everyone. It's kind of crazy. Okay, so let's have a look at some concepts you'll need to know for standard course. Now here you'll see an example of a network labeled from A to F. Now these dots, we're going to call these vertices from now, or vertexes. So the dots are your vertices and these ones are your edges. So if you want to put it into context, let's say these are 6 friends, or maybe that's not a good thing because that's a connection between itself, but let's say these are 6 cities and the vertices represent the cities and the edges represent the roads connecting the cities. So it's quite easy to conceptualize. Okay, that is just a standard network. Here, what you see here, you've got arrows, which means it's like a one-way. Well, these are called directed networks. So for example, here you can imagine just a one-way pipeline of water flowing through from A to F. Okay, now sometimes you also see these things here which have numbers on them. And when they have numbers on them, these are called weighted networks. So the numbers on the edges represent the weights, and they could represent anything. They could represent a distance, they could represent a time to travel, they could represent the cost in building something. So there's really limitless things you could use those numbers to represent within a network. So there's a lot of different examples. Okay, now let's quickly look at the idea of degrees and whether things are odd or even. So what does that mean? Okay, so what's a degree? So a degree is basically the number of edges connected to a vertice. So it's the number of edges connected to a let's call it a vertex here. Okay, so for example, if I change my color, how many edges are connected to A? Well, that's 2. So A is gonna have a degree 2. How many edges connected to B? Well, I've got 1, 2, 3 coming out here. So that's gonna be 3. How many coming out of C? That's obviously 2. D, let's leave D to the end. E, you have 1 obviously, and F, you only have 1. Okay, now D is interesting because how many edges do you have coming out? You've got 1, 2, 3, 4, 5, 6. Now some kids get confused because it's the number of edges going in to the vertex. So you've actually got a double up with this loop. So it's 1, 2, 3, 4, 5, 6, 7. That is 7. So a loop will count as 2. Okay, now let's just do one more to be sure here. Let's look at this one here. This will be degree 1 because there's 1 edge. B has 1, 2, 3, as you can see, 1, 2, 3. So I'm going to label that with 3, C has 2, D has 2, E also has 3, F has degree 1. Okay, so far we've covered what a vertex is and what an edge is, and also a couple variations of different type of networks you'll come across. All right, let's look at an example, one more example here. Find the degree of each vertex in this network. Okay, so just quickly, A has 2 connections, B has 1, 2, 3. C has 1, 2, 3. D has 1. And E has 1, 2, 3 as well. Okay, so that's question A done. Now, how many vertices are even? Now, even here just represents like odd and even numbers, so 2, 4, 6, 8. So I've got an even one for 2, and I've got it. No, that's it. I've only got one vertice, which is even. Okay, so one vertice, which is even. All right, so the next part. Here we want to look at the idea of moving through a network and going from one vertice to another, and the different types of paths you can take or routes you can take along the network. So if you look on the left-hand side here, there's quite a few definitions. We'll go through them one by one, but I'll give you a simpler way to remember them in a little bit. So a walk is just any route along the edge of a network. So for example, here, A to B, that is a walk. A to E to C, that's also a walk. A, E, C, B, A, that's also a type of walk. So basically anything. Now, closed in this sense just means it starts and finishes at the same vertex. So if I go A, B, A, that's a closed walk. Now, closed will apply to different types of other routes. So for example, I'll talk about that in a little bit. So the next one is a trail. So a trail is a walk with no repeated edges. So a trail is a walk with no repeated edges. So A, B, C, E, and let's say it goes back to B, so it doesn't repeat any edges. It repeats a vertice, but doesn't repeat any edges, so that's a trail. A circuit is a closed trail. So a circuit is a closed trail if it starts and finishes at the same place and it doesn't repeat any edges. So let's say it goes A, B, C, E, and then back to A. That could be classified as a circuit. Let's look at the next one. So a path. A path is a walk with no repeated edges or vertices. So there's no repeating of anything. So A, B, C, E. And a cycle is a closed path. So you start and finish at the same place. So let's say I go C, B, E, C. So simple enough. Now note the last vertex. See how I start and finish at the same place? Well, that obviously doesn't count as going to it twice because it's closed. All right, now I get that it would be quite hard to remember this, which is why I've created this decision tree, which should hopefully help you decide whether or not yours is a walk, a regular walk, a trail, a path, a circuit, a cycle. So we won't delve in this straight away too much. Let's just try and apply it and then see what we can get from there. Let's have a look at this example. So state whether each walk is a trail or a path. So straight away, we're just deciding if something is a trail or a path. So let's look at the first one. G, B, E. So G, B, and then to E, then to M, then to K, then to E. So G, B, E, M, K, E. Now, let's look. So does it repeat any vertices? Well, it does, doesn't it? Because I'm going from G to B to E to M to K and back to E. So, yes. Now, is it close? So does it start and finish in the same place? No, because we started at G and finished at E, so it must be a trail. All right, cool. Let's look at the next one. The next one is G, M, K, E, B. So G, M, K, E, B. So do we repeat any vertices? No. Is it closed? So does it start and finish in the same place? No. So this has to be a path. All right. Cool. Let's look at the next one. So B, E, G, B, E, G. And then we're going M, K. So M, K, B, E, G, M, K. So do we repeat any vertices? I don't think so. Is it closed? So it doesn't start and finish at the same place, so it must be another path. Okay, 2 more. So EB, G. So again, EB, G, M, K, E. All right, so looks like we've got something different. So does it repeat any vertices apart from the start and the end one? Let's double check. So EB, G, M, K, E. So no. And is it closed? Well, yes, it starts and finishes at the same place. So this must be a cycle. Okay, last one. G, let's get rid of this first. G, B, E, K, G, B, E, K, M, E, G. So G, B, E, K, M, E, G. So do we repeat any vertices? Yes, we repeat E, I think that is. So like this. And is it closed? So does it start and finish at the same place? Yes, it does. So we start and finish at G. So this must be a circuit. All right, so we've covered quite a bit here today. We've covered different types of networks and different walks or different routes through the network, and also the degrees and whether or not they're even or odd. So it's quite a bit of information. I hope it's succinct enough. As always, I'll leave the notes down below. If there's any questions, just let me know in the comments. Otherwise, I'll see you in the next one. Peace.